So can we find out what the equation of a polynomial is if we're given some roots, -1, -2, 0, and 0, so multiplicity of 2 on those zeros, and some extra information. It has to go through a certain point when x is 2, y is equal to 1. So, okay, well, let's start by writing down our function, and then this means that you have to have x plus 1 as a root, and this means that you have to have x plus 2 as a root, and this means x, and so does this, so that's x squared. And if I just tidy this up a little bit more, it's more like maybe x squared, x plus 1, x plus 2. But I also have to have it go through this point. And so one thing that we haven't really talked about is, what if we multiply this whole function by some value? We'll call it a. Well, now I can actually solve for that a value if I have some extra information. This extra information is f of 2 is 1, which means when x is 2, y is 1. So that means this whole function is worth 1 when the x value is 2. And now I can actually solve for what my a value is. So this side is 1, and this is a times 3 times 4 times 4. That's 4 times 4 is 16 times 3 is 48. So if I divide the right-hand side by 48 and the left-hand side by 48, I get a is 1 over 48. And I know that this polynomial, 1 over 48, times x plus 1 times x plus 2 times x, so I'll throw those in front. That polynomial goes through this point and has all of those roots. And if you don't believe me, go ahead, grab your graphing calculator, make that function y1, and check it and see if it actually goes through all of those points. Use the table feature, see if it goes when x is 2, if it goes through the value y equals 1, and hopefully you can see that I'm not lying, that this is the process of creating a graph that goes through certain points and has certain qualities that you want. And we can do the same thing if we're given a picture. So for this last example, let's see if we can come up with the equation of the polynomial that has the qualities of this sketch. And the sketch will just look like this. Basically, it's all the same information I just had in the last question, but in a visual form. So one of the roots is going to be -2, and then at 0 we'll make it a double root, and it'll go up like this, and we'll give it a point that it goes through of being 1, 3, 1 comma 3. So start off with your function. Write down an a value. Now that we know the a value is quite important, write down your a value and then start listing your zeros. So this point here is a single zero, x plus 2 to the power of 1. This point here, though, is another one of those doubles because it bounces. It's a double root, so I get x and I get x again. So I know that my roots are -2, 0, and 0. That's how I'm forming that part. Now I also know that when x is 1, y is 3. So there's my y value being 3, and if my x value is 1, I have 1 squared and 1 plus 2. So a times 1 times 3, 3. Divide both sides by 3. I know my a value is 1, and I don't even need to write it down. So 1 x squared times x plus 2. And I'm done. Notice that you can also see this in some different ways. If you expand this out, that's going to be a positive cubic, and this is a positive shape of a cubic. It basically fits that shape as well. Okay, we'll get some practice in class. See you then.